How did the geometry teacher and the track coach wake up their son? They tell him it's time to rise and run. And why rise and run? We're going to be talking about slope and equations of lines, and slope is a big part of equations of lines, and you may recall it comes from the rise over the run. So we're going to start by graphing the line with slope 4 that runs through point A 2, 5. So there's the point. I went over 2 and up 5. And then my next point is going to, because it's a slope of 4, I need to do a rise of 4 and a run of 1. Up 4 over 1. And so my line looks like this. So what must be true for any point x, y on this line? Well, the slope must be 4. The slope doesn't change. It's always going to be 4 on a line. So rise divided by run is 4. So I'm going to use this to set up an equation. I'm going to pick a random point, and I put it up here on purpose so you wouldn't know what the coordinates were. And one thing, we're going to have the rise here and the run there, but it's not 4 and 1 anymore. It's a little bit different. And I know these coordinates are x, y. So this rise is going to be whatever y is minus 5. So if y were 8, the rise would be 4, but it's not. Then the run will be whatever the x coordinate is minus this x value, which is 2. So that's the run, x minus 2. So it looks like y minus the y coordinate for the original point over x minus the x coordinate for the original point equals the slope. So does this work as an equation? Well, I'm going to go ahead and use it to test a few points. So here's my original equation that I just came up with. Y minus 5 over x minus 2. So the rise over the run must equal 4. And I'm going to see if the point 1, 3 is on the line. Well, I substitute in 3 for y and 1 for x. 3 minus 5 is negative 2. 1 minus 2 is negative 1. This is not 4, and it's not on the line. And you could probably figure that out. Here's 1, 3. Definitely not on the line. How about 4, 13? Well, that one's definitely harder to check out because that's kind of going off the screen. So again, I use the same equation and I substitute in 13 for y and 4 for x. 13 minus 5 is 8. 4 minus 2 is 2. 8 over 2 is 4. So yes, it is on the line. Now what about our original point? Our point is 2, 5. Can I use the same equation to test it? So I'm going to go 5 minus 5 all over 2 minus 2. Well, this gives me 0 over 0, which I don't know. Is that 4? Because I don't know how to divide by 0. So is there a better form for the equation of a line than this, where I go y minus the y coordinate over x minus the x coordinate equals the slope? So what I'm going to do is I'm going to go ahead, if I didn't divide by 0, this wouldn't be so bad. So I'm going to go ahead and multiply both sides by x minus 2. Well, what does that do? It's going to simplify. X minus 2 divided by x minus 2 is 1. So my new equation is y minus 5 equals 4 times x minus 2. So do you see these original values from our original problem? We have the coordinates for the points, and the point was 2, 5, and there's our slope. So what if I were to change the slope or the intercept for this line? Let's start with the slope. If the slope is 7, how should the equation change? Well, just this value right here will change. That was the slope. It becomes 7. If we also change the point to 4, 9 with the slope of 7, what does the equation look like now? Well, here was 2, 5 where the point was. Now we're changing it to 4, 9. So this 4 should go with that too. And 9 should go with 5. And there we go. We get y minus 9 equals 7 times x minus 4. So this leads to the point slope formula, which is a very powerful form. It's a form I strongly recommend you try first. Y minus y1 equals m times x minus x1. This is on your math chart. And remember, it comes from slope. If I divided both sides by this would just look like rise over run equals slope. So here's an example. A line has slope of -10 and passes through the point -2, 3. What is the equation of the line? Well, we're going to go ahead and write down the point slope form. So x1, the point, is -2, y1 is 3, and the slope is -10. It's a very simple substitution. So you're going to leave y here without the subscript. That's a subscript right there. And you're going to leave this x alone. So the two that are in black here are not going to change. We only substitute in for these colored portions, y1, m, the slope, and x1. So now I get y minus 3 equals -10 times x minus -2. And that is my equation of the line. I could make it a little simpler. Y minus 3 equals -10x plus 2, just to get rid of that minus minus. I'll be going over other forms because we're frequently going to ask for a different form, but this is what you're trying to get to first. So for further reflection, should the slope stay the same or change for a straight line, and why? What is the problem with substituting in our original point for the equation we created from the slope? And what type of information do you need to use the point slope formula?